So great job exploring where earthquakes are located in Bhutan. Hopefully, after seeing these experiences, we can start to interpret some patterns about these locations. For example, out in eastern Bhutan, we see there are many earthquakes located on the surface. And in western and southern, we do have some earthquakes, but there seems to be an absence of earthquakes, particularly in our northern regions. So, what's going on here? Why do these earthquakes have patterns? To interpret these observations, we need to look more into our understanding of earthquakes. And at the end of the day, when we look at what an earthquake is, they are related to this phenomenon known as faults. A fault is where two blocks of the Earth's crust suddenly slip past one another. And so there are many faults across the entire crust of the Earth, some big, some small, and they come in different sizes. We're going to break down different types of faults next week, but for now, just know it's this movement, and especially when there's sudden movement along a fault, that is where an earthquake occurs. So if you can imagine this cartoon being of Earth's crust, you can see that when you have a fault and these arrows indicate motion, that's an offset in the crust, and this release of energy is what's causing our earthquakes. So some few things to remember about faults, and we can think of them in time scales or temporal scales. Now, the typical average rate of movement for faults across the world can be summed down to around 1 millimeter per year. But this is average over hundreds and thousands of years. So in reality, faults don't actually behave this way. They're not just moving small by small step each year. In reality, faults have strain that builds up over decades, centuries, thousands, and millennia of years. And eventually that strain in a fault, that buildup of energy, reaches a threshold, a breaking point, and it's finally released. So then everything will give at once. A good analogy is to think about these faults and earthquakes like a rubber band. You can take a rubber band and keep pulling it, right? Building up energy until finally you get to a point where it's so big that it'll finally snap and release all that energy at once. When we think about this release of energy, we can think about it in a spatial scale. So as soon as that fault gives way, adjacent lengths along that fault will also slip, generating those seismic and surface waves that we saw last time. An important word to know about this is the hypocenter, which is the actual breakpoint along the fault within the Earth's crust. Now, these can range from close to the surface to, in some places, a few hundred kilometers deep, or around 70 kilometers deep. But generally, they're within the upper layers of the Earth's system. And so, the term we learned in the last video, epicenter, is the point on the surface of the Earth that's directly above the focus, directly above the hypocenter. So if here's our hypocenter right here, which is the actual release point of the fault, our epicenter, where we could find the surface expression, would be directly above that. Notice how it's not necessarily on the plane of the fault if the hypocenter is deeper. Epicenter above. Great. So looking at this release of energy, let's talk about it a bit further on how to measure these earthquakes. So we talked in our first session about intensity, which is the strength of shaking at a particular site. But again, for measuring and comparing earthquakes, because that intensity is variable, it's not our best data point. we can look towards. Instead, what scientists use is the measurement of magnitude. And magnitude is the measurement of a size of an earthquake. It's the maximum motion that's recorded by a seismograph, and it relates to the amount of energy that's being released. And magnitude can be a bit of a confusing topic because it's measured in a few different ways. The one thing that most people are familiar with is this idea of a Richter scale. However, this Richter scale is not commonly used anymore because this uses a formula which tends to be only accurate for local events. It was first developed out in California, and it showed that the amplitude, the amount that a seismograph would shift due to an earthquake, was relative to that earthquake's location. So Richter scale is good for talking about the magnitude of local earthquakes, but in order to, a more globally recognized phenomenon now is this measurement called moment magnitude, which you should be familiar with. So the moment magnitude is actually based on the physical properties of an earthquake, based upon the mechanics and dimensions of a fault. And it measures the earthquake in size in terms of energy, actually being able to look at components like the rigidity of material and the dimensions of the fault to understand how much energy was needed to produce that shaking. So our moment magnitude is really important. So the moment magnitude produces a scale that's relatively similar to the Richter scale, but it's measuring it in a more accurate and comparative manner. So this scale produces numbers which are relative to the energy that's being released. And essentially, the lower the number, the less energy, and then less correlating effect. Right? The larger the number, the greater energy that has been released, the greater slip that has happened along these faults, and the more destructive potential that earthquake has if it's located in an area that's well populated and not as prepared. So thinking about this idea of magnitude, let's go back to our example of Bhutan. And we're going to do one final earthquake inquiry. I'm going to show you a map of now plotting the different magnitudes of these earthquakes which you looked at. And so my questions for you are, where are the largest magnitude earthquakes in Bhutan? And then, knowing that these earthquakes are related to faults, what can these earthquakes tell us about the location of faults for Bhutan? So here, I'll show you really quickly. This link on VLE beneath this video will take you to this website right here, which is just this online map. And so it's really cool. You can see our legend down here that will express the different magnitude of earthquakes that have happened here. And again, you can click on these to learn more about them. What I want you to do is, looking at this map, come down here and use this draw mode, this draw feature. If you click on any one of these, it'll let you draw some different shapes. What I want to show you is this freehand. If you draw on here and scroll down to select this orange color, I want you to highlight and try to circle areas where you find the most intense earthquakes here in Bhutan. Right? And then with the same orange color, once you've identified these areas with earthquakes, knowing that this earthquake intensity is related to faults, I want you to try to draw where you think faults might be located here in Bhutan. Try to use this earthquake to mark these earthquake information to mark up where you might imagine faults would occur. Then, once you've drawn on your map, you can come back over here to layers. And we actually have a layer for the different faults in Bhutan. After you finish drawing, I want you to click on this layer to add in and see how your interpretation matches up with faults that have been mapped here. And we can see more. Okay, good luck, and I look forward to seeing your maps.